Hi, it's Mr. Olivier, and I'm here with a special guest today to learn about rocks from the sky, meteors and meteorites and all the wonderful things that fly through space. And here we have Ron.
Hi guys, my name's Ron St. Martin. I'm the former meteorite coordinator for the Royal Astronomical Society of Canada in Ottawa here. I've been buying and collecting meteorites for over 25 years now. So you can say meteorites are part of me. They're a very big passion of my life right now.
Here is some important vocabulary. Meteoroids are space rocks. Meteors are when meteoroids enter the atmosphere. Meteorite is when a meteoroid hits the ground. Asteroid, a minor planet. So Ron, tell us, how did you begin collecting meteorites?
I purchased my first meteorite at a gem and mineral show, to be exact. Bought my first one, and ever since then I've been hooked. I started doing research on them, and now I have way too many meteorites.
Excellent. And can you tell me, which one is your favorite meteor?
One of my favorite ones is probably this guy right here. This is a brecciated meteorite from Argentina, or from Algeria, sorry. And this one here, you can actually see the little bits of pieces that make up the total mass of the meteorite. It's very cool.
There's gravity working for you, bringing all those pieces together. Excellent. So can you tell us a little bit about the different types of meteorites?
Well, there's three main types of meteorites. There's stone meteorites, which are basically rock. Then there's iron meteorites, which are basically all iron and metal. And then there's our stony iron meteorites, which are nickel and iron meteorites, which contain bits of pieces of olivine crystals, like this one I have right here from Kenya.
Wow, that's beautiful.
This one is coated, of course. You can't see right through it because it's not thin enough, but usually we cut them thin enough so you can see right through the olivine. They're very beautiful crystals. They represent about only 4% of all meteorites found.
I do believe I've seen one at the Canadian Museum of Nature of these.
This is a big stone meteorite. This is from Algeria. This is NWA Northwest Africa 869. This is one of my favorite stone meteorites just because of the burnt fusion crust on it. It looks very beautiful. They have good weight. They contain about 7% nickel and iron in them. Now here's a big slice of that same meteorite, and you can see the little bits of nickel and iron in them. And if you look closely, you see all these little round bits inside the matrix here? Those are called chondrules, and those are little bits of solar nebula from when the solar system was being formed. So they're untouched for over 4.5 billion years old.
Incredible. Wow. The ages are hard to fathom.
Here's another really nice one that you can really see the chondrules in them. This is a carbonaceous chondrite.
So, am I correct in saying some of these carbonaceous chondrites would have formed before our sun and Earth?
Yes, I do have one in my collection that was found in Mexico in 1946, I think it was, called the Allende meteorite, which when aged with radioactive isotopes, we found that it was about 500 million years older than our solar system. So it actually immigrated from another solar system. And when scientists examined it, they found 13 amino acids in it, and they only recognized 9 of them. So there are 4 that we have never seen before.
That's incredible.
This one here, this is almost a 2-kilogram meteorite from Argentina called the Campo de Ciel. This one was first discovered in 1576 by Spanish conquistadors when they landed on what's now Argentina. They discovered the natives there were using pieces of it to use for weapons and tools and such. We didn't realize it was a meteorite until the early 1900s.
Wow.
And this is a very beautiful meteorite. You can see all the fingerprinting, or rigomaglyphs they're called, and that's from the melting when it was coming through the atmosphere.
Let me feel the weight of that.
It's very heavy.
Oh my goodness, it is heavy.
A lot heavier than it looks. This With nickel and iron meteorites, when we slice them and etch them with nitric acid and ethanol, it brings out this pattern called a Wittmann-Statten pattern, which is only found in meteorites. And if you didn't know what that was, all the different crystals in there are different kainite and taenite crystals that are cooling at different rates over billions of years. Most nickel and iron meteorites come from the core of failed planets or large asteroids that have enough gravity to actually produce enough heat to melt the metals and send them down to the middle of the asteroid.
Interesting, interesting.
This is another beautiful meteorite. This was the Sekote Alain. It was first discovered, it was actually a very well witnessed fall in 1947 in Russia. Now they're still finding pieces of it embedded in trees and stuck in the ground everywhere. Very beautiful meteorite. You can see this one was very oriented, so all the melting occurred on one side of the meteorite, where the other side is all barely untouched. And it almost broke into two pieces.
Wow. Interesting.
There's another really cool one here. This one here was found in southern Egypt. It's called the Gebel Kamil. Now this meteorite's been on Earth for over 13,000 years, and we just discovered it about 4 years ago. Somebody using Google Earth was looking at mountain ranges in southern Egypt and found this crater, and when the scientists went to look at it, they found a 20 by 40 meter crater full of these meteorites scattered all over the place.
Incredible. You know, a lot of people, when we look up at the moon and see all the craters, we forget that our Earth has been hit so many times. And of course, with vegetation and weather, we don't actually see the evidence of it. Everything is hidden, but every once in a while you can see a crater here and there. So
it's funny that you should mention the moon. I'll just put it down like this. Oops. Can you see that okay?
yeah.
That little guy right there is an actual piece of the moon.
Incredible. A lunar meteorite. Have there been any pieces of Mars found as well?
Very much so. They find a lot of them. Most of them, funny enough, they're finding only in Antarctica.
So what is these? These two are quite interesting. They look like glass.
Well, it's funny that you ask. These are typically glass. These are called tektites. And these are a result of a large impact. It impacts with such force that it actually melts the sand into glass. So you can see this is a tektite from China. And you can see where the broken surface here, you can see the glass is very dark. So where this impact occurred, there was a lot of vegetation and a lot of water and stuff. And then if you go down, this one here, this is a piece of Libyan desert glass. So you can see where this impact occurred. It occurred in the desert, so it was pure desert sand, so the glass is a lot cleaner. Fun fact about Libyan desert glass, when they examined the chest plate from Tutankhamun, there was a scarab on his chest plate, and it is actually made of this Libyan desert glass.
That is that's amazing.
Yeah. And this particular one, I know everybody wants to look at this one because it's one of the coolest meteorites I have. The shape of it is amazing. You can see the melting in it. This is a meteorite that fell in Russia in the year 2000. Now the strange one about this one here is when you cut and etch this one here, it does have no Wittmann-Statten pattern at all. It's a very strange type of nickel and iron meteorite called an atoxite.
Wow, I never even knew that existed. That is so cool. It really looks like it's almost in motion. It's like has these flow lines. That's due to melting, I guess, right?
Yes, sir, yeah. Most meteorites typically lose about 80% of their mass as they're coming through the atmosphere. So you can imagine this one is about 5 or 6 times bigger than it is now.
So a meteor that's coming through the atmosphere that, say, is the size of a car, about how big do you think that it'll actually reach the ground?
Most meteors, if they're over about 1/2 ton, most of it actually hits the ground.
Okay.
Because it's got enough weight that it could punch right through the atmosphere before it starts melting. And then after it punches through the atmosphere, it's so hot, that's when it explodes, and then you get pieces of shrapnel flying pretty much everywhere.
Okay.
They typically hit the atmosphere at about 40 to 45 kilometers per second, which is pretty fast. So whenever you see a meteor or a shooting star, it's not actually the stone or the meteor that's melting, that's causing the bright. It's the air that's in front of it, because it's causing such friction that it's burning the oxygen in front of it. And that's where all the heat comes from.
Very interesting. Okay. Thank you so much, Ron.
Thank you very much.
I hope you enjoyed that. That was amazing.